Welcome back to the deep dive. You gave us the sources, and well, now we're digging in, extracting those key insights you need on the generative revolution that's changing pretty much everything. We're kicking off a whole new series today. This one's called The Age of Synthetic Media. And for this first part, our mission is really foundational. We need to cut through the buzzwords, define what synthetic media actually is, how it's fundamentally different from, well, all the media that came before. And crucially, look at the technologies, the real architectural pillars like transformers and diffusion models that made this new reality possible.
Yeah, and it's so important we don't just see this as like another tech trend. It's more than that. What we're seeing is a qualitative break, a real shift. For years, AI was mostly a tool, right, for automation, maybe helping sort data you already had, but now it's an active co-creator. It's generating complex, coherent stuff, visuals, text basically from scratch. That doesn't just change how media is made, it changes what media is, fundamentally.
Okay, right. Let's unpack that. That's a huge claim, a seismic shift. So maybe start with the basics. What is the core definition of synthetic media?
Okay, so synthetic media is content, could be visual, audio, text, you name it, that's artificially created or heavily manipulated using deep learning, neural networks. And the key difference, like our sources point out, is this. Traditional media, think photos, videos, writing. It aims to capture reality. Record something that exists.
Right, capturing versus generating.
Exactly. Synthetic media generates. It can invent entire worlds, characters, things that might have absolutely no basis in the real world.
That distinction feels really profound. And the data comparing them, it really highlights this, doesn't it?
It does. Look at the creation process. Traditional media, you're out there capturing footage, writing text, you're bound by physics, the camera, the real world. Synthetic media, it's really only limited by the algorithm and the data it learned from.
Which leads to that incredible speed difference everyone talks about.
Oh, absolutely. Making a high-quality traditional piece like a commercial or animation that takes days, weeks, sometimes months. Specialized skills, lots of people. Synthetic content. You can go from an idea, a prompt, to a finished piece in minutes or hours.
Minutes versus months. Wow, that explains the explosion we're seeing. But it also brings up huge issues around authenticity,
Definitely. Traditional content captured by a device usually comes with metadata you can, in theory, verify. Location, time, device info. With synthetic stuff, those natural markers are just gone, and any metadata attached. It can be faked just as easily as the image or video itself.
So you basically need an algorithm to tell you if another algorithm made the content.
Pretty much. And this isn't just theory, it's big business. The sources are projecting the global synthetic media market will hit over, $10.23 billion this year?
Yeah, that number jumped out at me.
And it gets wilder. They're forecasting $77 billion by 2034. That's a compound growth rate over 17%. Massive expansion.
Those are just staggering figures. But you have to wonder, are they truly sustainable? Given all the uncertainty around, training data rights, IP, how we even define what's real or authentic anymore?
That is the multi-billion-dollar question, isn't it? I mean, that valuation assumes the tech keeps accelerating and the regulatory side doesn't slam on the brakes too hard. But the growth we've already seen is undeniable, and it's all built on these foundational technologies we should probably get into now. We wouldn't be having this conversation without them.
Right, okay. Let's look under the hood then. To understand that growth, we need the tech. And it's worth remembering the precursors, right? Before the current boom, we had things like variational autoencoders, VAEs, back in 2013. They were stable, but the images were kind of blurry, soft.
Yeah, not super realistic. Then came the generative adversarial networks, GANs, in 2014. That was a big leap.
GANs, right, the adversarial concept.
Exactly. You had two networks competing, a generator making stuff, and a discriminator trying to tell if it was real or fake. That competition really pushed the quality up, but, and this is a big but, the sources highlight they were notoriously hard to train, really unstable. And they suffered from this thing called mode collapse. Basically, the generator gets stuck in a rut and only produces a few types of images, losing variety, kind of like an unstable prototype.
So GANs showed the potential, definitely, but that instability was a major hurdle. We needed something more robust, something that could handle massive data sets reliably.
Precisely. Which brings us to the modern era, really kicking off in 2017 with the transformer architecture. If GANs were that first kind of unstable visual spark, the transformer was the revolution for language and sequence processing.
Okay, the transformer, big name. What's the core idea there? Because self-attention sounds a bit abstract.
Yeah, it can be. Think of it like this. Older models, like RNNs, had to read text word by word sequentially, like reading a long book one page at a time, trying to remember what happened chapters ago.
Okay, that makes sense.
The transformer's self-attention mechanism is different. It's like it can look at the entire document all at once. For every word it processes, it calculates how relevant every other word in the entire text is, no matter how far apart they are.
So it can connect, say, the subject at the beginning of a paragraph to a pronoun way at the end, instantly.
Exactly. It grasps for these long-range dependencies. That ability to see global context, plus the fact it can process all words in parallel, not sequentially.
Parallel computation, yeah.
Faster and smarter.
Right. That combination is what enabled the huge large language models, the LLMs, that we hear so much about. GPT, BERT, all those. They could suddenly process and understand context across vast amounts of text.
And that scale led to something interesting the sources mention, emergent capabilities.
Yes. That's fascinating. These are abilities that just sort of appear once the models reach a certain massive size, things they weren't explicitly trained to do.
Like what? Well, the sources show examples like LLMs trained only on text suddenly being able to do basic math or write working computer code. Nobody programmed that in. They kind of taught themselves, extrapolated from the patterns in the language data.
Wild. Okay, so the transformer cracked language and context. But for really high-quality, stable visuals, we needed something else to replace the unstable GANs, right?
We did, and that's where diffusion models came in, really taking over for images and video starting around 2020 or so.
Diffusion, how do those work? The process sounds different.
It's quite counterintuitive, actually. They don't start with, like, a blank canvas. They learn the opposite of creation. They're trained by taking perfectly clear images and systematically destroying them, adding noise step by step until it's just static.
Adding noise.
Yeah, Gaussian noise usually. And the model's entire job is to learn how to precisely reverse that process. How to take the noisy static and step by step clean it up back into the original clear image.
Okay, so then when you want to generate a new image, you just run that reversal process. Start with random noise and have the model denoise it into something meaningful.
Exactly. Often guided by a text prompt telling it what to denoise towards.
Clever. But wasn't that incredibly computationally expensive at first?
Hugely. Doing that denoising process in the full high-resolution pixel space that needed massive resources, think Google-level infrastructure.
Right.
The practical breakthrough, the thing that put it in reach for more people, was latent diffusion.
Latent diffusion. Okay, what's the key idea there?
Instead of working on the giant high-dimensional image itself, latent diffusion works on a compressed, sort of lower-dimensional representation of the image. Think of it like working on a highly compressed blueprint rather than the full-scale building.
Okay. So it's doing the heavy lifting, the denoising, in this smaller, compressed latent space.
Precisely. And that compression drastically cuts down the computing power needed. That's the reason why you, the listener, might be able to run tools like Stable Diffusion on your own computer now. That was basically impossible just a few years back.
That really democratized things, didn't it? Making high-quality image generation accessible.
Totally. It gave us better quality than GANs generally, much more stability during training, and importantly, better control, making the output stick closer to the text prompt.
Okay, so we have the transformer handling context and language, and diffusion mastering stable, high-fidelity visuals. What happens now? The sources talk about convergence.
Right. This is where it gets really interesting. These powerful but separate technologies are fusing together. We're seeing the rise of unified multimodal model.
Multimodal, meaning they handle multiple types of data, text, images.
Exactly. Text, images, video, audio. The core idea is multimodal learning. You convert all these different data types into a shared mathematical format, usually called embeddings. Think of them as specialized numerical vectors. And you align these vectors in a common semantic space. This means a single model can now reason across different modalities. It can understand the relationship between a picture and a sentence describing it because it represents both in a similar way internally.
Okay, I think I follow. Can you give an example?
Sure. A really foundational one is CLIP contrastive language image pre-training. It was trained on hundreds of millions of image-text pairs from the internet. Its job is basically to learn which text descriptions go with which images. So when you use a text-to-image diffusion model, CLIP is often working behind the scenes, constantly checking how well the image being generated matches your text prompt. It guides the diffusion process.
So CLIP provides the bridge between the text understanding and the image generation.
You got it. And this fusion is now tackling the big one, video. Models like Sora, which made huge waves recently.
Yeah, Sora. How's that fit in?
Sora is described explicitly as a diffusion transformer. That name tells you everything. It uses both core technologies.
How does it handle video data? It seems much more complex than static images.
It treats video and even image data differently. It breaks them down into smaller units, kind of like data patches. And crucially, it handles these patches like tokens in a large language model.
Like words in a sentence.
Exactly like words in a sentence. By turning video frames into these token-like patches, it can then use the transformer's self-attention mechanism.
Ah, so it could look across the entire video timeline, just like a transformer looks across a whole document,
Yeah,
to understand context over time.
precisely. And that's how they're tackling the massive challenge of temporal consistency.
Temporal consistency, meaning making sure things don't just randomly appear or disappear or change in the middle of a video, which plagued older AI video attempts.
That's the one. By treating video like a sequence of tokens with long-range dependencies, the model can maintain coherence. Objects stay put. Scenes evolve logically over time. That's what allows for these longer, high-definition, prompt-driven videos we're starting to see.
Okay, so pulling this all together, it's not just separate tools for text, images, and video anymore.
No, not at all. They're becoming interconnected parts of a single, unified creative pipeline. Your idea might start as a text prompt, which generates a visual concept or storyboard, which then gets animated into a scene, maybe even with AI-generated sound or dialogue layered on top. It's becoming a much more fluid workflow.
That sounds incredibly powerful for creators.
Immense opportunity, yes. This convergence is arguably the ultimate democratizer of creativity. Tools that used to require years of training and expensive software are becoming accessible to anyone who can write a clear prompt. It potentially breaks down that barrier between imagination and actually creating something, freeing people from purely technical limitations.
But there's always a but, isn't there? The sources hammer this point home too. The same power has a serious downside.
Absolutely. It's dual-edged. The ability to generate incredibly realistic deepfakes or just churn out massive amounts of convincing synthetic content at scale, that leads directly to what the sources call a profound crisis of trust.
Yeah, you can see why. Misinformation, propaganda. It can be created faster, cheaper, and look more real than ever before. How do you maintain journalistic integrity or even just a shared sense of reality in that environment?
It's a huge challenge. Navigating this future isn't just about building better tech. It requires a real commitment to responsible innovation. We have to harness the creative side, obviously, but also urgently develop and deploy robust ways to verify content, to detect synthetic media. The challenge is social and ethical as much as it is technical. We need to redefine how we establish truth when machines become perfect illusionists.
Absolutely critical. Okay, so let's wrap up this first deep dive. The key takeaways for you listening. Synthetic media isn't just an iteration, it's a paradigm shift. We've moved from media that captures reality to media that generates new realities, often with unbelievable speed. This revolution stands on two main pillars. First, the transformer, unlocking contextual understanding in language with self-attention, giving us powerful LLMs. Second, the diffusion model, delivering stable, high-fidelity visual generation made practical by latent diffusion. And now, these pillars are merging. Text, image, video, audio, they're becoming part of one unified creative ecosystem, driven by multimodal AI. Now, if you want to take these ideas and see how they work in practice, maybe try out some of these tools yourself, you should definitely check out Ian Ochieng AI on YouTube. That's Ian, Ochieng AI. He's got great tutorials and deeper insights into actually using these generative tools.
Yeah, definitely worth a look. And maybe we can leave you with this final thought to chew on. The future of media clearly requires more than just technical skill. It demands a serious commitment from all of us, really, to build the social, the ethical, the institutional defenses we need. How do we define authenticity? How do we maintain trust in a world where machines can perfectly mimic or entirely invent reality? What new frameworks will we be forced to create?